trivia. Now, be careful reading that question. It's not, maybe not what you think it is. War franchise is one of the most awards at the Game Awards. Notice it doesn't say year. Otherwise, the answer would be obvious.
Is this going to be on the exam?
Yes, this will be on the exam, absolutely.
Oh, yeah.
All right, so yes, the correct answer is Final Fantasy. Claire Obscure, however, did absolutely run away with it. Every category for which it was nominated, it won. So I've heard. If I can get over like that weird French aesthetic, I might play it. How many of you guys even know what banana is? Okay, I think banana is finally falling out of fad. Banana is a stupid clicker game, basically. That rose to, like at one point it had something like 5 million concurrent players on Steam. It was ridiculous. All right, we got Tree. Welcome, Tree. Obamason, Taven, Sanjay, and Kleb. I kind of give this one to you, but you know. I found that image and I couldn't help it. All right, cool. Vast majority of you got it. I'm not surprised that inshodification is on some of your radar because it's really a term that, although it was coined back in 2023, it's been recently, especially with the rise of AI and all of the abuses that come with it, that inshodification is truly come to the forefront where it's gained popular recognition. Sag is something my boys say. I don't know what that is. Okay, say no more. Streamer chat lingo, that's all I needed to hear. All right, now we get to the meat of it. We've got 18 questions of real stuff. Questions very similar to what you would see on the exam. Almost all of you got it right. What is a process? All right, so generically. I mean, there is a science of process engineering. I don't think any of you industrial engineers. I don't think so. So, context of process in a running program. Although you can't think of a sequence of steps to do anything to be a process. In the context of this class, a process is a running program. And a few of you are having a time with life, aren't you? I'm sorry. Hope things get better. All right, so we have Tatum, Tree, Amelia, and Obamason. And it's really close, too close to tell. It's really, really tight for that top 5 slot. I'm betting that it's really close all the way down to like number 10, probably. Anybody's game. Ooh, what is going on here? What is not? See, I can see why some of you might be confused and not think of the list of open files because files are something really external to a process, right? You know, you're opening your readme.env process. But the thing is, we need to keep track of that. We need to know when a process terminates, or not terminates, but when a process is descheduled, we need to know what it had open. We need pointers to all that stuff. So even though open files are external to our processes, they are in fact a part of its machine state. We need to know what those files are, what state they were in, so that we can correctly restore the complete state of that process on return. All right, still way too close to call. This is a good game. It's rare for me to see it like this close, but maybe that's because there's so many of you. I normally run like 20 to 30 player games, and you guys are like in the 70s. All right, 3 basic process states. What do we got? And please don't mind the comments in the images. I was in a rush, and that was the most clever thing I could come up with. All right, cool. Overwhelming number of you got it correct. In progress, in queue, or deferred. There is no in progress status. What does that mean in this context? We don't know, but there is no such in progress. It's simply running. In the queue is, again, not a state verbatim, but it is closely analogous, maybe a line, to ready, because what does it mean to be ready? It means to be in the queue. So your instinct wasn't wrong. Where your instinct derailed you is that there's no such thing as deferred. What does it mean for a process to be deferred? Because the closest to deferred that I can think of is when a process chooses to yield. When it chooses to yield, it is deferring, it's giving up its time on the CPU to be put back in the queue, to be run later. But that's not a state, that's something that a process does to transition from running to ready. All right, so we're seeing a lot of movement here. I'm seeing some new names, Nick and Kay. Welcome to the leaderboard. E has a slight lead, but again, it's still too close, especially from the top 3 slots. Amelia, Austin, you have a very good chance of taking the top spot. Not saying that Kay or Nick, because all it takes is one mistake. If E were to goof it up and were to flub even just one question, that would make room available for Amelia and Austin to come in and take the top spots and move everybody up with potential. Cool. Most of you got it completely right. Real mode and protected mode. Now, interesting. Those are real CPU modes. So, I really wish, because that's where this comes into play. Because in the beginning, most computers there wasn't the sense of we have to protect processes from each other because there weren't multiple processes. There was just one. And that was true back in early x86. And when I mean early x86, I mean coming up to and including like maybe early Windows 95. And so that was, back then, they called that running in real mode, which means, this is scary. This will be really scary once we get into memory. Like when we start talking about memory, what this will, the implications of this. Applications had full access to memory. They could directly address physical memory. Why is that a problem? Well, I wrote a program in assembly that overwrites the first 64 kilobytes of physical memory. Guess what that did? instantly killed the entire system. So we had real mode, and then later we had protected mode, where we now finally offered virtualization services because the CPU now had memory anymore. And we'll get into that when we talk about memory. On and off. I would sure hope that CPU support all work cut out for you. You can do this. It's entirely possible for somebody to come from 5th, even 6th or 7th, and take the game. Alright, cool. Most of you got the CPU. We would have to define what CPU overload is, and there isn't a good definition of CPU overload. Because then that gets into how do we detect an infinite loop? It's that kind of problem. So there's really not a good way to measure what do we mean by overload. Does it mean running it 100%? Well, what if it's running for 100% but for a very short amount of time? That should be okay, right? Well, what if it's running 100% for 5 minutes? Is that okay? It depends. What's it doing? Is it processing a large amount of numerical data, like it's doing gene sequencing? In which case, maybe it's going to run at 100% for half an hour, several days. So we don't really have a good definition for CPU overload, much less a way of addressing it. And then, of course, the correct answer is non-cooperative processes have these unruly children that hog the toys, or, oh, what's the old joke? Mom says it's my turn at the Xbox. So that sort of thing. So we can say, all right, Billy, you've had enough time at the Xbox. All right, Sally, you can play now. No motion at all. All right. Wow. Most of you got this right. A few of you picked completion time and response time. All right, so completion time is not a metric. It is not a metric. It is something, it is data that we pull from our Java runs, but it's not a metric because completion time doesn't tell us anything except when it completed. Well, all right, so let's say that a process completed at 50 seconds. So what? Did it run? Was it scheduled at 0? In which case, okay, that tells us something. Because 50 minus 0, that means it was in the system for 50 seconds. That tells us something. That's turnaround time, right? But what if, again, same idea here. We've got a process that terminates at 50 seconds. But what if it came in at 49 seconds? What does that tell us? Really not a whole lot. Actually, it tells us a little bit. It tells us that it was immediately scheduled. Oh. Which means that the response time is 0 because it came in at 49, completed at 50. So it got to run, it got in there, it was immediately scheduled, and ran for its time slice and ending. But that 50, that number by itself doesn't tell us anything. All right. So response time. All right. So what are we looking at here? Now we got to actually look at the question. The time from job arrival. Okay. Cool. Because like all of our metrics start with, you gotta know when you came into the system. All right, to job completion. So that's the entire time that it's spent in the system, including wait time, by the way. Ooh, we need to talk about wait time. Wait time is, it's kind of implicitly understood, but I need to like actually make it explicit so you don't get surprised by the exam. But that's its entire time in the system. And we call that the turnaround time. Response time, on the other hand, is how quickly from the time that, boom, I asked for that process to be loaded, to the time that it actually gets on the CPU. That is response time. All right, let's see what we got. Oh, feel free to interrupt me at any time. Questions, concerns, memes. All right, no motion. No motion. That's interesting. But now there is a roughly 3 to 400 point gap between fourth and third. But it's still doable. E has it going. All right. Most of you got it right, but a few of you say it unfairly penalizes the first job schedule. It's quite the reverse, actually. It's the first job schedule that gets all the benefits of FIFO, because first in, first out, which means that, remember the convoy effect. So if a huge process comes in and it happens to get there first, it gets to run for completion. Key thing, remember, FIFO is non-preemptive. Means that once a process gets scheduled, it runs until completion. So first, the processes that get there first get the benefit of terminating first. Ooh, Caden, welcome, Caden, welcome. But everything else is staying roughly the same. All right. E is still not managing. So at this point, what I think is going on here, and I think at least between the first 3 spots, maybe the rest, I'm not sure, it's coming down to reaction time, response time. Okay? See what I did there? It's all down to, I put the question up, the process is in the queue. How quickly can a process get to your brain and process and come out? So maybe it's not response time, maybe it's turnaround time. Yeah, that's right, it's actually turnaround time. Because when you submit the answer, the job is completed. I load the job, I load the question, right? You guys, it comes in into your eyeballs and gets cued in your brain, and it has to remember, it has to compete with all of these other thoughts. What am I having for dinner tonight? Should I go home and buy Claire Obscura? Yes, you should go home and buy Claire Obscura. Should I, what time am I waking up tomorrow? It's got to compete with all those thoughts. And your brain, the scheduler, has to make sure that that input gets priority. Then, once it's on the CPU in your brain has to think about it, has to reach back into memory, and then draw things from long-term memory into short-term storage so it can be worked by the neural system to select the correct answer. And it is only until you selected the correct answer where that entire pipeline is fully executed and we have the turnaround. Which means, by the way, this is my recommendation if you want to succeed at this game. Do not use round robin. You will be penalized for round robin. Why? Because all of those other thoughts that come into your head while you're looking at the question every other thought we've got going on about dinner, about hanging out with friends, about playing video games, all of that stuff has equal time. So this question is going to be delayed, even though it might get to your brain quick, but it's only going to run for a short amount of time. You know, it'll run just long enough for you to recognize the words that are on that question. And then what goes on your brain next might have a run tonight again. So you might actually want to switch to something like a priority queue. Maybe an LQ might work for you. Maybe FIFO with priority, not FIFO. What about, let's do shorted SPCF because we want it to be preemptive. But we added another layer of priority so that you can tell it when these jobs come in, give it the highest priority. Ooh, I just talked about this. All of you should get this. But again, switch your scheduling. Ooh, that's such a mix. Where are you guys? Oh, I know why you guys are confused because I intentionally made this confusing. And I think, unfortunately, with what we just talked about, there might be increased pressure for the instant response performance. So, yeah, this is intentionally a confusing question, at least in the presentation of the choices. What is response time? All right, you guys should be able to tell me. What's response time? Thanks. That was useful. I'll make sure to put that in the textbook. All right, you know, tell me how do we calculate response time? You're pointing, but at what? Yes, in the back.
Like how things first, like in general, how things first perceived versus what time it takes for us to react to it.
Oh gosh, you're making it so much complicated. It's really a simple formula. I mean, it's here. It really is here. It is the time that it's first scheduled on the CPU minus the arrival time. That's it. That's all there is to response time. So time first scheduled minus arrival time. All right, so let's talk about, I am so glad that very few of you selected green. Because that was like, I was kind of tired, and I'm like, I'll just throw in a doofy one, and I'll just include something with context switch time. That'll get me. And I caught a few. But the context switch has nothing to do with response time. It has nothing to do with arrival time, because that is turnaround time. It is not arrival time minus time for schedule, because that inverts the formula and you get negative time. And the only way that you can get negative time, as far as I'm aware of, is quite possibly with a quantum computer powered by a black hole that creates closed time-like loops that then you can, I don't know, entangle quantum particles and then be reading information from the future. I don't know. But that'll give you negative time, which won't work. Oh, damn! I'm sorry. I'm so sorry. That question must have thrown you for a loop. Holy cow! And Greg and Julianne, welcome to the club. Austin and Amelia duking it out for first place. I told you guys, anything can happen. So some of you, right, so what is, one of you picked green. Get out! You're trolling me, I know that now. Anyway, all right, so 26, so what's the confusion here? Let's take a look. So we know the Q value is basically the minimum amount of time that we're granting each process. We take a process and we chop it up into pieces, and each slice is the minimum minimum amount, oh my gosh, minimum amount of time that we grant. So every process gets to run for at least that amount of time. So let's look at blue. The maximum amount of time a process can run. Notice that I didn't put any qualifiers on it. What's the maximum amount of time a process can run? Is it a minute? 2 minutes? You get to run Microsoft Word for all of 2 hours? That would be a mercy, by the way. So, no, we can't put a limit on maximum amount of time a process can run. Yes? Because the idea is, remember with round robin, it's the idea, something that I didn't mention, it's going to be on the exam. Round robin is called the fairness algorithm. It's called fair because every process is guaranteed a quantum. So if we say that the quantum is 3 seconds, every process gets its 3 seconds. In traditional round robin doesn't care if it yields. So typically what happens when a process yields or is terminated, then that triggers round robin. Oh, I just don't find the next process to put in its place. So, yeah, it could yield, but it doesn't have any impact on like which other processes are scheduled. Unlike you're thinking of MLFQ, where if a process yields before its quantum expires, it means, oh, it stays at its priority level because it didn't consume all of its quantum. If its quantum were, say, 3 seconds, my scales are way off by the way. If it was 3 seconds and it ran for 2, and it yielded, then the next time it gets put on the CPU, it'll get put on its previous priority. And if it starts at the highest priority, which they do, it'll retain that high priority until it yields again. And again, because it didn't consume its time slice, it gets run again at high priority. So it's a way of gaming the system, of making sure that your process always runs on top. All right. Ooh, hey, welcome back. I know that's hurting my throat, right? Austin, Amina, Katie, and Tree. I haven't seen you for a while. Tree, good buddy, pal, long time no see. What is the trade-off of making the round robin time slice very short? And there's an interesting counter question for this that I'm going to ask you, because I want you to think about this. Ooh, you guys are all over the place today. Most of you got it right. Better response time with higher context switch overhead. Or the way I described it in class is the shorter your time slice, the more time you're spending in the context switch. So you have to be careful in selecting your Q value that you're allowing yourself enough time of doing the real work. Not that context switching isn't real work, but it's overhead. Proportional. You want to reduce the proportion of time spent context switching. I believe the book says you're amortizing the cost of context switching by doing it less. However, there is a trade-off. What happens if you make the Q value too big? So if we make the response time too long, we might end up back at something like SJF or even FIFO. Our performance degrades to the point where the round robin doesn't matter anymore. Because a long process comes in, it can stay on the CPU for an extended amount of time, and our performance degrades to approaching that of FIFO. So you don't want either, so you don't want to cut your time slice so short that you spend a high proportion of time doing context switching, but you don't want it so long that you degrade performance back to FIFO. Yes?
The other ones, the second question one saying that the turnaround time would be longer, would that be sort of a result?
Oh, hang on. Let me see if that lets me go back. Good catch on that. All right, so better response time, but worse turnaround time. So it is better response time, but the kicker here isn't the turnaround time, because the shorter we make it, the more impact context switch has. So yes, technically that's true, but because of context switching, it kind of doesn't matter. So it's a technicality. I should grant or change that response, because that is technically true. All right, what do we got? Julian and Clem. Welcome to Clem. Yeah, I can tell like there's probably maybe the first 15 slots are like really close together. But we have E, Austin, and Amelia all vying for the top 3 slots. And it's still literally anybody's game. And sorry that I didn't like mix these up.
We'll just be posted, or does it?
They are public, and I can post them. All right, cool. All right. The 9 of you that selected free. And I'm being sincere here, like straight up. Where's the confusion? And I mean that's a sincere question, because I need to know like what's going on in your head. Where's the misconception? Where's the mismatch? And it's okay to speak up. I'm literally like no means to ridicule you or anything like that. I just want to know what was your line of thinking when you selected true for a program, processing program are the same thing. All right. By the way, when I ask that, I mean it, because I want, like, part of what I do as an educator is try to figure out how you guys are thinking so that I can debug your thinking. And so that in my teaching, yes?
When I get to confused, they both start with being similar word here, which is the higher level one, which is, if I'm not mistaken, a process is like a program can spawn multiple processes.
Yes.
Okay.
Yes, absolutely. So help me out here. What's a good mnemonic that we can use for distinguishing them? That's a good point. They both start with pro. They're roughly the same length. I can see that being a confusion. So what's a good mnemonic that we can use here? Like the only thing that I can think of is you program in C, and so you compile your C code to a file. So a program is that file that you compile. And then a process is kind of this abstract thing, like there's no tangible expression of a process.
You program a program and the CPU processes.
You program a program and a CPU because it's the central processing unit. And what does a process do? It runs processes. Sure. All right. Oh man, it's still so close. So close.
What's the name of this tool so we could find it?
It is CFP 4600 processes, dash processes. Sorry, I couldn't find a robin that was round enough. Remember what it is that round robin does to processes. Ooh, okay. All right. So round robin, scheduling optimizes turnaround time. No, because remember, when we chop up processes over time, what are we doing? We're spreading them out over time. The more processes are in the system, the longer it will take any individual process to run, because it's going to be spread out amongst all those other processes, at least while those processes are in the system. And so this stretching out effect of slicing it up will have the effect of worsening turnaround time. Turnaround time in round robin is much worse than under the other schedulers. So no, round robin makes turnaround time worse, not better. However, if you're looking for response time, round robin's a good choice. All right, nothing changed. All right. All right, awesome. Not much to talk about here because we've already talked about it. What's the time to interrupt, dude? Ding, your turn's up. All right, no motion at all. Dang, that's close. All right, so a few of you didn't get this. All right. So remember, MLFQ multi-level. What are our levels? They're queues that we place processes in, and each queue represents a priority. So multi-level feedback queue. What's the feedback process? The feedback process is we look at how much time a single process spends on the CPU. If it consumes its quantum, we denote it. That's the feedback loop that's involved here. And you can get into situations where long-running processes get starved out. Why? Because they're running at the lowest priority. But if you have a lot of short-running tasks, like a lot of interactive tasks, then it's possible for that long-running process to never get back on the CPU or get to the CPU very seldom. Thus, starvation. So remember that starvation in general is when we cannot allocate enough resources to, or the resource, to a particular consumer. So process isn't getting through the CPU. So how do we fix it? Well, one easy fix is we snap our fingers and half the processes disappear. No. We raise all of the priorities and make every process top priority instantly. What does that do? That creates chaos. But it's kind of good chaos because it gives these longer running processes time at the higher priority to get actual work done. And the hope is, maybe we can flush out some of those longer running processes that we're on the verge of finishing. So we bring it up to the top, and it has just enough time to say, oh, thank you, I am done, I am out of here, see you later. So that's what the priority boost does. It is meant, remember, it's like giving the box a whack, or shaking the container, right? You want to loosen things up, you want to get things flowing again, and that's what boosting priority is. Man, that's close. I found a funny picture of Robin. False. Can you tell me why? What? Because it takes time to switch. Right. So the shorter the time slice, the more of it, of course, you're context switching more often, which means you're engaging overhead more often. All right, are we settled? Are we up at the last note? We still got a few clusters left. All right, most of you got this right. Here you pick green, which is only halfway understandable, because you're looking at that and you're going, oh, that when I do an ls minus l, that's what I see. So if I do an ls minus l on my hello executable, I get the program size, the ownership, the group ownership, and permissions. Problem is, all right, technically some of this is part of this thing, it's not really. These are all attributes of the file, of the program itself. This is not what is tracked by the operating system in memory. What we're tracking is we're tracking register context, and what we mean by that is the values of the registers. The current state, running, blocked, ready. The process ID, because we need a unique value to identify each process so that we can index into it quickly in the process list in memory. Memory information like its address space, and the list of open files, which we talked about earlier. Ooh, Julianne, moving in at number 3. Awesome. Learning is a bit of a strong word here. Or, as folks say, learn is doing a lot of work in this sentence. All right, most of you got it right. MLFQ, correct? Because essentially it says, if you consume all the quantum, then I'm going to assume that you're going to consume a lot of CPU, so you're going to be a long-running task. I will deprioritize you. All right, 9.
Did we talk, didn't earlier, like, the whole problem with shortest time to completion versus that we don't necessarily know how long a program takes?
Correct.
So doesn't shortest time to completion first, like, scheduler also have to have some kind of system like that where it learns which processes are?
No, shortest time to completion only care, and remember, shortest time to completion operates under the conceit, the assumption that we know how long a process is going to run. hold true in real life. We don't know. That was good, back in the day, back when we were submitting batch jobs to like mainframes and, room-sized computers, but nowadays, you don't know. And so, the beauty of MLFQ is it's responsive. Like, it tries to guess what processes are going to use up a lot of CPU and respond accordingly, based on how much queue time it takes up. And jump forward to CFS. CFS has even more mechanisms that it uses to try to basically intelligently guess how processes are going to use the CPU. So, most of you got that right. 9 of you chose GPT 6.0. And in all fairness, I did go on at length about why large language models are not particularly well suited for operating system tasks like this. Because they're just simply too complex. By the time that you've run through your model, oh my gosh, how much time has passed? Especially if it would have to be a local model. And local models are slow, unless you've got a beefy CPU or a beefy GPU. So then the rest of you said shortest time to completion first, which I think was what you were getting at. And the only way in which we can say that it knows about the future is because it operates under the conceit that we know how long the process is going to run. But in reality, that is never the case. And in fact, shortest time to completion first doesn't learn, but rather it looks at and it says, oh, you've got the shortest time left to go, you get to go on the CPU. Whereas MLFQ is actually making choices based on a prediction. No movement? All right. Ooh, you guys are all over this. All right, let's walk this through. Shorter time slices increase schedule overhead, because shorter time slices means that the scheduler has to make decisions more often. To prevent gaming, this doesn't prevent gaming at all. In fact, it encourages gaming by saying, okay, if you run under the time slice, you get to stay at the high priority. We cannot reduce context switch time. Context switch time is essentially a constant that is derived from your architecture and the operating system. Whatever mechanism, however the operating system implements the context switch determines, and the CPU performance determines your total context switch time, which is constant across all of the algorithms. Which leaves they contain interactive jobs that benefit from quick alternation. Because that's the whole idea. Remember, each queue is a round robin queue. And so if we keep the higher queues with the higher priority at shorter time slices, that means that response time benefits, which means that interactive applications are snappy and responsive. All right, I think that was question 20. It was. All right, do we have any surprises? Julianne at number 3, congratulations. Coming in from number 4 to number 3. That's not bad. And wait, what? Austin! Way to go and congrats! So did you do what I recommended? Did you switch out your scheduler? Is that why you suddenly got the top spot? Awesome, awesome. Congratulations, everyone who participated. Let's go ahead and claim our rewards. Oh no. What is this? Oh God, what is this, Animal Crossing? Uh-huh. No, they did this, they started doing this like a year ago at least. Oh, no, I can explore the item, all right. No, I don't want to explore the item, thank you very much. All right, so, before we head off, I know you guys are anxious to head off, I'm going to, do that. You know why I'm doing that? Can you guess? Because I'm gonna open up the exam. All right, let's take a look at the exam. But first, can I get out of this screen? All right, there we go. Okay. All right, so I'm going to go over, in the last few minutes, I'm actually going to go over, like, maybe topics, questions that weren't covered in the group. Where are we? Right here. Making sure that it's not, yes. Oh, the groups. I'm missing what the current group situation is. Okay, there are no groups, and I would have to manually build it out. Okay, so I'm going to ask you guys this question. I'll leave it up to, I'll experiment a little and leave it up to your preference. All right. Would you prefer that I randomly assign you to a group? Raise your hand if that sounds good to you. Oh. Oh, wow. Okay, I'm going to say that's about maybe 15% of you, maybe 10? Okay. I'm surprised. All right. How many of you don't want to be in a group at all? A bit fewer than the last group, but still good. All right. So based on that, not many of you want to be randomly assigned. Understandable. It's just easy for me because I just click a button and we're in groups. And I never have to worry about it. Because here's the thing. But you guys, can you guys even join the groups the way I've got things set up? Give me a second, because I actually have to work out some technical logistics here. Because I did something to reduce a genuine pain in the ass. Oops. We're going to do allow self-sign up. Create groups now. There's 200 of you. I'll go ahead and start us off with 40 groups. Limit of 5. Save. All right, now I need somebody to go ahead and see if you guys can join a group. Because I did stuff to kind of, yes?
Just a quick question, do we have to use ChatGPT or could we use something like Claude that doesn't something coding?
Okay, this question comes up every single time because I haven't updated the assignment, which is on me. You can use any LLM you want, but find some way of providing me a link to your conversations. That's all I ask. All I ask is, give me an easy way to see your conversations. That's why it's ChatGPT, because ChatGPT has share link, and then you can just, in your write-up, you just include the link to your conversation, and that's it. All right, so has someone successfully joined a group? All right, cool. All right, so here's the answer. Groups are optional. You may choose to join groups. If you want to join a group, but have trouble with the social element, I have created, or at least it should be here, under discussions, the looking for group. You know, it took me a until like last month to realize that LFG, most people, most of you guys know that as let's fucking go. Like it took me, and I've been using LFG for years because I'm an old MMO player. So I know, like intuitively, LFG, looking for group, everybody knows that. Apparently not. All right, so there's an LFG thread. If you are soliciting and saying, hey, I'd like to be in a group, or hey, I'm starting a group, come here, go chat amongst yourselves. Two things that I recommend very strongly for all of your projects. Have a GitHub and have a Discord. Those two. Okay, fine, you can use Slack if you want to, like you're like a boomer. But have at least a GitHub, have some way of collaborating on it. All right, so that answers the group question. Will be, all right, now let's actually open up the exam with all 7 minutes we have left. All right, let's go do a quick preview. All right, remember, it's at the EPC, so I hope you have your appointments already. All right, so one of the things that we just like glossed over it in a sense are the 3 easy pieces. Be familiar with what those 3 easy pieces are. In other words, be familiar with the overall content of this class. So understand system calls and how they work. There is a question on here that I fully intended. I want there to be a historical component, a deeper historical component to the first day's lecture, but I never get to it. So what I want you to be aware of is how does MS-DOS compare to the operating systems that come before it? It's a very important historical question that has some really interesting and far-reaching ramifications. All right, understand the states and the flow between states. What happens when a process requests I/O? Understand the components of a process. What's the heap? What's the stack? Just like in our quiz, understand what are the strengths and weaknesses of each respective scheduler, especially the basics. I don't think I have a whole lot on MLFQ, but that might change when I update the exam over the weekend. But at least understand, like, all right, what does Robin do really well? What was the motivation for STCF? Things like that. And I asked this question during the Cahoots. So what happens at the various extremes of Q value under round robin? Oh, I did have some MLFQ in here, which we covered during the Kahoot. All right, and then the rest are the short answer. And then finally, I have a scheduling problem where I will go ahead and tell you we're doing STCF, no problem. I give you an arrival time and burst time for each process. There's 4 processes in total. And you can come over here and do need to show this. We're at the end of the sorry about that, thanks for pointing it out. Okay, so let's go back to modules, let me show you. So, under module 1, under processes at the very bottom, supplemental material, the process scheduler solver. So this is just a good way to give yourself some practice time. So here we go, shortest remaining time first. It's another name for STCF. So choose STCF. Let's go ahead and do 0, 2, 4, 6, 8. Burst time 5, 2, 1, 3, 4. Arrival times, the number of them must match burst times. And then what you're going to do is you're going to sit down with a sheet of paper and pen, or maybe Google Sheets, however you want to do it, and you'll go through and work it out and work out all the various metrics. Oh, and yes, we never covered waiting time. Let me go over waiting time real quick, because it's kind of implicit, right? So we know that with these various schedulers, that especially the preemptive schedulers, that once a process gets scheduled, to the time to completion, there may be some time where it's not doing anything because other processes have been scheduled in its place. So what do we do then? Or how do we take that into account? That is called waiting time. Waiting time, the math is super easy. Barely inconvenience. We're going to take completion time, or turnaround time, sorry. We take turnaround time. That's the entire time is spent in the system. And subtract from that the burst time, or the CPU time of the process, meaning the time that it actually did really work. So if its turnaround time is 10 seconds, and its burst time was 4, that means that what happened to the other 6? So the 6 was spent waiting, and it's wait time. So turnaround time minus burst time gives you your wait time. And so you can see here, and it shows you the Gantt chart. For those of you having PTSD from USD, you have a Gantt chart that shows you the sequence in which your processes will run. And then you can just use this for practice. Give yourself different values, different number of processes if you're feeling ambitious, and work and do this repeatedly until you have a good sense of it, and you can work out the final answer without fail. Because this is really, like, this is not even algebra, this is arithmetic. You just have to know how the different schedulers work. And like I said, I already gave you a big hint as to which one we were going to use, which I probably shouldn't have, but whatevs. All right, and that's it for the file.